Okay, so I'm looking at the integrand, and the integrand looks a little bit difficult. Now, let me write this down. Really, what I'm looking at is x raised to the power x over ln x. All right, so a couple of things I know about this. I know x has got to be greater than 0 because it's a natural log function on the bottom there. All right. The other thing I got to make sure is that the natural log of x, well, it can't be 0, right? So x can't be the number 1. All right. So I'm going to say x greater than 0, x not equal to 1. Now, when you take Calc 2, that's Math 122, these are going to be places where it's indeterminate. But right now I'm going to say that what I'm going to do is going to be valid provided x is greater than 0 and x is not equal to 1. All right? So what I want to do now is something that, certainly it might take a while to stumble on. You might try U substitutions, all kinds of things. But right now I'm going to try something a little bit different. All right? So let me get my eraser out. And I'll just summarize what I just said. I said that x is greater than 0. And the x is not equal to 1. All right? So what I do is I take the integrand, which is x to the power x over ln x, and I'll just say it's a function. Now, just like you did with logarithmic differentiation, you took the log of both sides to get the exponent to come down. Do the same thing. So it's a natural log of the function. The exponent would come down. You get x over ln x, and then it's going to be ln x. What happens over here? These cancel off, although conditionally they cancel off. Certainly under these conditions they cancel off. And what would you left off with? Just an x. And you get ln f of x. Now remember back to logarithmic differentiation, you rewrite it, get rid of the logs, when you get e to the x. So I'm going to claim that f of x is e to the x, which is really the same thing as x to the x over ln x. And again, this is true, provided x is greater than 0 and the x is not equal to 1. At these places, at the 0 and at 1, it's indeterminate. All right? So what are we going to do now? I guess we'll do the integration. So the integration is, x to the x over ln x dx. Well, the same thing as e to the x. Again, provided that these conditions are met. And what do you get over here? Dx. And what's it going to be? E to the x plus c. And what do you get over there? Let's write this down. You'd get, let's see, well, e to the x plus c, or if you prefer, x to the x over ln x plus c. All right, answers listed for you over here. Thank you.